All right, welcome to lesson 7.3. We're going to be talking about double angle formulas today. So to get started, we're going to use our compound angle formulas from yesterday. Those are our A plus B formulas. We're going to use those, our A plus B or our A minus B. We're going to use those to simplify the following expressions. So I'm going to start with sine of theta plus theta. And I'm going to use my A plus B formula, thinking of the first theta here as A, but actually B is the exact same angle, it's another theta. So I know that this formula says to do sine of the first angle, so sine of theta, times cos of the second angle, which is also just theta, plus cos of the first angle, theta, and sine of the second angle, theta. And then I'm going to simplify this and see if I can clean this up. So what I actually have here is sine theta times cos theta plus, and because the order of multiplication doesn't matter, this is also sine theta times cos theta. So I actually have 2 sine theta times cos thetas. Now on the left-hand side, I can also clean this up. Inside the bracket, I have theta plus theta. Well, that's just 2 thetas. So what I have here is sine of 2 theta is equal to 2 times sine theta times cos theta. So we call this a double angle formula because if I have sine of double the angle theta, I can simplify that out in terms of just theta on its own. All right, so part B, we're going to take a look at cos theta plus theta. This one's a little bit more complicated because there's many versions of this formula. So we're going to use, again, our compound angle formula from yesterday with the A plus B. So I'm thinking of the first theta as A and the second theta as B. So for this formula, we do cos of the first angle times cos of the second angle, but they're both just theta. And then if it's addition inside the compound angle, then I'm going to subtract between the ratios. And so sine of theta times sine of theta. And again, I can simplify this here. I've got cos theta times cos theta. That's the whole thing being squared. And when we write that in trigonometry, instead of writing cos of theta squared, this is really confusing. Like, what am I squaring here? Am I squaring the angle or am I squaring the ratio? So you can technically fix this up because right now it looks more like you're squaring the angle, which is not what you want. You can fix it up by putting brackets like this, but because we write this so often in mathematics, we don't want to always have to write these brackets. It looks very cumbersome and messy. So instead what we do when we mean the whole thing being squared is we write the squared in here on the cosine. So cos squared of theta means cos theta times cos theta. And then we can clean up this second expression in the same way, sine theta times sine theta, that's sine squared theta. And then I can clean up the left-hand side. This is cos of 2 theta, if I have theta plus theta. So this is one version of cos 2 theta. But we're actually going to do a couple of different versions here. So this is one version. It's going to come in handy sometimes, but sometimes it's inconvenient for me to split it into 2 different ratios. Sometimes I don't want cos and sine mixed together in one expression. So in that case, what I'm going to do is try and get rid of one of these, and I'm going to use a trig identity from grade 11. We know from grade 11 that sine squared theta plus cos squared theta, that's actually equal to 1. We call it the Pythagorean identity when we're in grade 11. Well, you always call it that. Notice that cos 2 theta kind of reminds us of this because it's also the squared of the ratios, but here it's subtraction, and cos has to come first in cos of 2 theta. It's cos squared minus sine squared. You can't reverse the order. What I'm going to do, though, is use the Pythagorean theorem to get rid of one of these guys. So let's say first I want to get rid of the sine squared theta, and I only want to have coses here. Well, then to get rid of the sine squared theta, I'll come over here, and I'm going to move the cos squared to the other side of the equal sign so that I just end up with sine squared. So I'm subtracting cos squared from both sides, and it tells me that sine squared is the same as 1 minus cos squared theta. So I'm going to substitute this into my expression here. And then what I get is that cos 2 theta is equal to cos squared theta minus 1 minus cos squared theta. Notice that it's important that I put that in brackets because I'm actually subtracting the 1 and I'm subtracting negative cos squared theta. So that becomes plus cos squared theta. And then I can simplify this. I've got a cos squared plus another cos squared theta, and that gives me 2 cos squared thetas minus 1. And this is the second version of our cos 2 theta. I use this version when I want to end up with just cos thetas. So I want to get rid of the double angle, but I want to just have cos thetas and no sine thetas. But similarly, maybe I don't want the cos thetas. Maybe I only want sine thetas. And in that case, I'm going to use that same Pythagorean identity from grade 11, but this time I'm going to rearrange it so it looks like cos squared equals. And when I do that, that means I need to move the sine squared theta to the other side and subtract it. So I'm going to sub that in to my original equation. So I'm working from here, and I'm going to sub in cos squared theta equals 1 minus sine squared. And now when I simplify this, I can again collect like terms. I'm subtracting 1 sine squared and then subtracting another sine squared. That's the same as subtracting 2 times sine squared. And this is the third version of cos 2 theta. So again, if I want to get rid of the double angle, but I want to end up with sine thetas, I would use this formula. All right, and then part C, oops. In part C, we're going to take a look at what happens when I have tan. So for tan, I'm going to use my tan of A plus B formula from yesterday, my compound angle formula, and that tells me to do tan of the first angle plus tan of the second angle. And then I'm going to divide by 1 minus tan theta times tan theta. And then I can simplify this. I've got tan theta plus tan theta. That gives me 2 tan thetas all over, and then I've got 1 minus tan squared theta. And then on the left-hand side, I can simplify this as well. I've got tan of 2 theta. So this is my last double angle formula. Oops. And you can see that they're summarized here in the box. That's all the formulas that I just came up with. I'm going to pause the video here and then we'll keep going.